Hi, I am Anatin Bensel, and this is my final project for CSCI-89B, Natural Language Intro to Natural Language Processing. My final project is a case study in finance, and I'm taking a look at whether natural language processing can predict which economic news events actually move the markets. And I just kind of want to say that I have also taken CSCI 989 at the same time, so I'm using a little bit of what I've learned there. And also CSCI 278, which is applied quantitative finance, and I'm using some information from there. So this project has kind of been a great amalgamation of all the things I have been learning so far. And I'm going to jump into what kind of economic news I'm looking at, which is a red folder event. So if you've ever looked in at trading economic calendars, you've probably seen these red folders next to a release. And red basically just means pay attention. So editors manually decide that a CPI report or an FOMC decision deserves a red folder, while something like a regional business survey usually doesn't. It's useful, but it's also like one person's judgment call made ahead of time with no guarantee of its consistency. So for this, I asked two separate questions. First, is there enough structure in the wording of these calendar entries that the model could reconstruct the same judgment on its own? And second, and completely separate, do these events actually labeled red folders behave differently in the market, or is the label more tradition than substance? So my hypothesis going in, I had kind of four specific bets. I expected the TF-IDF, which is like that classic bag of words method, to do well because the economic calendar language tends to repeat itself a lot. I also expected a convolutional neural network to beat the bidirectional LSTM on theory that the red folder status is something you can pick up from a short phrase and not from understanding word order across a long sentence. I also expected top performance to drop once the model had a handle on event types it's never seen before, as opposed to just new dates. And then I also expected red folder days to show bigger price swings than non-red days. And just a little spoiler, three of these held up, and like, but not in like the simple way that I had originally expected. And that nuance is kind of what became kind of the heart of this project. So building the red folder database, the data set itself comes from the Forex Factory economic calendar. So that's like 21,000 plus minus USD events stretching from 2007 to 2025, like early 2025. And this chart just shows you kind of the class balance. So about 27% of the events are red folder and about 73% are not. And that imbalance really does matter because it's why we can't just look at the accuracy and call it a day, because the model that always guesses not a red folder would already be right most of the time. So the only thing the model ever sees is the event's title and the description text. So never the impact label itself, obviously, or it would just negate the entire purpose of this project. So red folder language, this is actually probably one of my more favorite charts in this entire project because I trained a simple logistic regression on text that pulled out words and pushed the prediction towards red folder, and which would push it away. So on the left, you can see the words that like scream red folder are like Fed and economic activity and statement and chair, and basically like central bank and broad economy language, which on the right though are the words associated with non-red events. And that's interesting because they skew towards specific years and like procedural words like member or listed, the narrower, kind of more technical indicators. And that to me tells me that red folder status truly is not random, and that the genuine vocabulary is basically how we can decide whether how big and how macro this topic is and how much impact it will have. One thing I do want to note is that there's a problem that's pretty easy to miss. So the same underlying release shows up under multiple names. And if you're not familiar with like economics and finance, prelim GDP, final GDP, advanced GDP are all really the same report, but they're just at different stages. And like CPI month over month and year over year and core CPI are all in the same inflation family. So this chart shows the biggest of these normalized event families after I merged all those variants together. And if you're wondering why that matters specifically for this project and this particular data, it's because if I split my data randomly, the model might see CPI MM or M/M, which is month over month, 900 times, and then get tested on CPI Y/Y, which would be year over year, which is basically the same words, just like kind of wearing a different outfit, I guess. So I didn't want it to test generalization, and that's then memorization. I wanted it to be honest about which ones it was actually measuring. Um, so I didn't jump straight into like a deep learning situation for this. I actually built up from the simplest possible baseline, which is a model that guesses the majority class. A handwritten keyword list, kind of looking for terms like FOMC or non-farm, then TF-IDF with logistic regression, which is fast and fully interpretable, and then two neural models, a CNN that scans the text in short, like 3-word sequences or windows rather, looking for red folder phrases, and a bidirectional LSTM that reads the whole sequence in both directions. And this chart in the background is the CNN's training curve. So you can see the training loss kept dropping while the validation loss flattens out, which is exactly why I use checkpointing to save the best version rather than the last epoch of my training. So this I kind of trained on 3 different levels of difficulty, and I didn't test each model once. I tested each model 3 different ways. So I did a random split, which is where I took the dates and the event families and kind of shuffled them together. I did a chronological split where the test period comes strictly after the training and time, which is more realistic. And then an event family split where I can hold like the entire families, like I talked about with like the CPI variance, so that the model has genuinely never seen the concept before. And each of these is really asking a different question at the end of the day, and you'll see that the answers are all very different. So, under the easiest conditions, the random split, the CNN is the clear winner over like 97% accuracy and had a PROC of like 0.988, which is like the metric that matters the most given how imbalanced this data is. So TF IDF is far behind here with a 0.928, which is honestly pretty impressive for something that's so much simpler. Which then means the results support my hypothesis that red folder status is really carried by short logical phrases rather than long context. And then the CNN whole design is built to catch exactly that kind of signal, and it shows. So the twist is when I made the TF-IDF face genuinely new event families instead of just the new dates, its PROC collapsed from the 0.928, I think it is, down to like 0.522. And like if you look closer at what's happening, precision actually stays high, and the 0.823, and the model says red folder, it's usually right, but the recall drops to just like 0.266, meaning it's now missing about 3 out of every 4 truly red folder events it's never encountered before. So, kind of, I guess in plain terms, the earlier 97% number was partially the model recognizing phrases it had memorized and not really understanding what makes something high impact. And that I really want to express as an important distinction if anyone ever wanted to deploy this like for real. So once the model was starting to produce the probability, I still had to look at whether or not I have to draw the line of this counts as a red folder. At the standard like 50% cutoff, the CNN gets 93% prediction and 97% recall. Raising that threshold to 70% actually balances the two best, landing both around about 95%. If you want to be extra cautious about false alarms too, pushing to 90% still keeps recall above 90 while the precision climbs to 97. So the reliability of the diagram on this is checking something different, which is more or less calibration. It's asking when the model says 98% confident, it's actually like 98% of the time, I guess, if that makes sense. So the line sits close to the diagonal, which means you can actually trust the confidence score and not just kind of like the yes or no answer. No model is perfect, so I went looking for where it breaks. And error clusters came the most around Fed speeches, housing data, and events whose real world importance has shifted over the years. So, like a Fed chair speaks event might be routine small talk or market moving policy signaling, and the title alone really does not tell you which. The chart on the right uses a technique called token masking, and I take a specific prediction, remove one word at a time and measure how much the model's confidence drops. So for core retail sales record, pulling out words like retail, sales, consensus cause the biggest drops, which tells us that the words actually are driving the call and there's not just like kind of a hidden pattern in there that we can't explain. So this is where I step outside of the text and check reality. I kind of joined I joined 4,000 event dates to price data for the SPY. And if you're in my grader for CSCI 89, I used ES, SPY, and VIX in my last project. So I joined that same data and the NASDAQ and some small cap ETFs and VIX and futures. The bar chart on the left compares the average absolute price movement on red folders versus non-red days across every asset. And red folder days are consistently a bit larger, and the chart on the right lists the single biggest SPY moves that happen on red folder days. And if you look at the dates, they cluster around October 2008, March 2020, April 2025. So you have the financial crisis, the pandemic crash, and this past year's volatility. And in other words, when the calendar said this day matters historically, then it actually proves that it does. So just statistically, 3 assets show real significant difference on red folder days: small caps, S&P futures, and SPY itself. While the NASDAQ and VIX don't really have a clear bar data situation. But my overall conclusion is the red folder label is real, and that genuine vocabulary models can learn, and it corresponds to genuinely different market behavior. But the single headline accuracy number depends entirely on what question you're asking. Like, can this model recognize releases before it's never seen before, and can it recognize something brand new, which gave me that 0.928 and the 0.522 respectfully. And only reporting the first one would have been misleading. On a practical note, I actually did put these findings to use, like I've mentioned, in this event classification and market patterns for this project actually, and in my CSCI 278 and then CSCI 89 project actually helped me pass a prop firm's funded account challenge, just trying to be able to use these things as market indicators of whether or not I should or should not trade, which was a really cool way to apply this in real life. But thank you for watching. I have the full paper, the notebook, my code, my slides in my submission. I'm happy to answer any questions. And I just want to say I really appreciate taking this class. And I am very grateful for the opportunity. Thanks so much. And thanks for watching.